Welcome back. Now in this class we will study determination of in situ density by core cutter method. Okay. What is the meaning of in situ? In situ. In situ. Situ means situation. In situation. That we will call it as a in situation. That is in situ. In situ density means you already know. Density means it is a measure of mass by volume. Mass by volume. That in situ density means what? You go to the ground. Do not disturb anything. Do not disturb anything. Do not take a pickaxe. Or otherwise do not take with the shovel. Do not take hari. Nothing. Do not take anything. Do not disturb this one. As it is, whatever the density is there here, that density you bring it to the laboratory and measure the density. That is called as in situ density. Okay, now how to achieve this one? How to achieve this one? That can be achieved by core cutter method. Okay, here in a practically these instruments are there in our lab also. You can see here this is a core cutter. Core cutter means a top opening will be there, bottom is also opening will be there. Here sharp edge will be there here. Sharp edges will be there. You go to the ground, level the ground. Here some stones or debris or trees grass will be there. You remove everything and make a flat ground. Then after that, this is the ground. After that you bring this core cutter and put it here. Put it here with the help of this hammer. This hammer suggestion is that from Indian standard its suggestion is it should be 11 to 14 kg. 11 to 14 kg. This is a hammer. And you now this is a collar. This is a collar. Sometimes it is called as a dolly. Okay, this is also called as a dolly. This dolly you put it on the this cutter, core cutter, and after that you take this hammer and put in a vertical position. You hit it up and down. You hit it continuously. Do not count number of blows, how many times you hit that. Do not count. Just you hit it so that it gently, slowly it will go inside. And when it goes inside, it look like this. See, this has went inside and your dolly is here. After that, by using a pickaxe, this is a pickaxe, and by using a shovel, this is a shovel, you excavate this surrounding soil. The surrounding soil you excavate. Do not disturb this one. And this as it is, how it is there, inside soil is there, no? That as it is soil, and this you bring it to the laboratory. See, I did not disturb the soil inside the cutter. That you bring it to the laboratory. Okay, now in an exam point of view, you need to draw this diagram as a core cutter. This is the cutting edge. This arrow should come here. This is a cutting edge, and this is a rammer. We will not call it as a hammer. Hammer means something like this, but it is a rammer. It is okay. And this is the dolly. Dolly will be about 3 centimeter, and usually inner diameter of the core cutter will be 10 centimeter, and the external height or otherwise internal height of the core cutter will be about 127.3 centimeter. Mm it is 12.73 centimeter. So why this odd number? Because when you get a volume, you will become happy. I will show it later. Okay, now this you got it. Then what to do next? When you perform the experiment, inside a soil will be there. Before performing the experiment, you measure empty weight of cutter. Call it as the M1. And after conducting this experiment and this experiment, when you bring to the laboratory, then you measure this mass. That is what? Cutter plus soil. Cutter plus soil, that is your M2. Then I want only soil inside the cutter. Therefore, soil in cutter equal to M2 minus M1. Then I got a soil in the cutter. Then fourth one is I want a volume of this one. Then volume of the cutter equal to area into length. Area is pi by 4 diameter square into length is a height. This is a height. Then here D if you substitute 10 and H if you substitute 12.73, you will get some magic number. I don't tell that magic number. You perform this and get it. That is called as centimeter cube. That many centimeter cube. This is a volume. See here. Very simple, right? And after that, what you do? Gamma bulk density equal to mass of the soil by volume of the soil. Mass of the soil is known to you. Volume of the soil is also known to you. You got bulk density. From the core cutter, from the top, from the bottom, from the middle, you take a 3 soil sample, put in the oven and do the water content determination test. And after that you will come to know water content. When you know water content, then you can perform gamma D. Gamma D equal to gamma B divided by 1 plus W. Very good. You got gamma D also. Now you take this soil, put in the oven, make it dry and perform specific gravity experiment. In previous class it is said. That experiment when you perform, then you will get a specific gravity. When you get a specific gravity, you can calculate White's ratio. White's ratio equal to G gamma W divided by gamma D minus 1. See, you got White's ratio. Very important. You got White's ratio, you got specific gravity, you got water content. Then from this you can get degree of saturation. Degree of saturation is Wg by E. Oh, no? You got it. When you know S, you can get AC. AC equal to 1 minus S. When you know this, then you can get Na. Na equal to N into AC. What is N? N equal to E divided by 1 plus E. See, all other are known to you. Core cutter method you performed and you came to know all the properties of the soil. Okay, na? Okay. We studied core cutter method. Now, see here, to determine in situ density, we have a 2 experiment actually. The first one is a core cutter method and the second one is a sand replacement method. Okay, na? Now we understood very clearly in the online only that how core cutter test is performed and how parameters are calculated. But sand replacement method is also used to determine the density, in situ density of the soil. Okay, na? But why we have a 2 method? Might be there are some demerits in the core cutter method. The core cutter method demerit is if the soil is sandy in nature, soil is a powder in nature, then when you put this powder that hit it inside, it will go easily. When you pick it out, no, this soil will fall down. No, it will not stick here. Therefore, this is one demerit. And the second demerit is, think that here is a one boulder. You don't know because this is a ground is filled by soil. Then you take your core cutter here and you will start hitting it. Then when it goes here, it will not go inside, or otherwise it will tilt like this. Therefore, you cannot perform core cutter method in all the condition. Therefore, we invented a sand replacement method. But this sand replacement method I will explain in the offline class. You just understand that sand replacement method is used to determine the in situ density of the soil. Okay, when you come offline, I will explain that. Thank you very much.